FunHouse MPU. It's got an early ROM revision in it, but the game is being rehabbed, and the fellow sent me the boards for checkout and rehab also, and it's a good thing he got them out when he did. You can see the corrosion easily discernible here and here, and U20 is also corroded. Now, you typically take that one out and socket it anyway, but there's corrosion there. These 10K pull-up resistors, you can see bits of corrosion under the solder mask here, and it's even gotten up here into this ceramic cap, and that looks like a 10K resistor on the camera. So there's nothing to do but to pull all these parts, sand it down to bare copper, and then rebuild the board. Display test panel for a FunHouse, testing in my FunHouse, and you can see it's operating perfectly fine. It was a royal pain in the rear end to test this, as cables weren't sent with it. Oh, that's interesting. I didn't know it did that test. All working fine. Take two, powering on FunHouse board set. And first of all, yay! No pop, no smoke, as was created by this tantalum cap at the tip of my finger. The last time I powered it on, I had already replaced one fried tantalum cap that you can see maybe down in there, and all the caps on this board, but it's always disconcerting to power on a board set and hear snap, and followed by smoke. Now, we do have one other problem that I can show you here. See, the center LED is blinking once. That is an indication of an error, and I'm pretty sure I know what it is, but let's consult the Wiki. This ROM version, I have updated it to 905H. And in the Wiki, let's see, a blinking D20 is indicating with one blink that there is a problem with the game ROM. So I'm pretty sure the fact that I updated this from a very old version of the game ROM, where is it? Right here. This was probably a 27 C010 or so, and the 905H is a different size, which is going to mean that I need to remove a jumper on this board. Now, let's do this in real time just for giggles. Since I authored a significant chunk of the Wiki, I know kind of exactly where to go for these sorts of things. So now we are on jumpers, and let's see, RAM size right there, ROM size. If we have a ROM of 2 or 4 meg, we need to install W1 and remove W2. Let's see what is present on this board. Here they are. Sorry. So this jumper is both W1 and W2. So I need to install W1 and remove W2. So what that's going to boil down to is moving this white 0 ohm resistor, or wire jumper as we commonly call them, down one position. So let me do that and I'll be right back. So I could not read the label on this ROM. Even after peeling the paper label up, the writing on the ROM was too difficult or impossible to read, so I had to resort to putting the ROM into my Chipmax 2 and having it self-identify it, and it is in fact a 27C010. And I am back. I have moved this jumper down to the W1 position, and let's boot up and see what happens. No smoke, that's all good. The diagnostic LED is blinking as it should right now, and we have an error message that says check fuses F1 14 and 15. A little hard to see as my display is a little washed out on a video, but that error message, error in quotes, is normal since this FunHouse MPU is looking for 2 of the optos that FunHouse uses, and if it can't find those, then it declares this error. But so far so good. Let's go through what I did to this board. I replaced a whole bunch of caps on this soundboard. 10 regular caps, two of the big 4700 microfarad, and a couple of tantalums. I may have to replace one of these sound ROMs. I don't remember specifically whether or not FunHouse 905 changed some of the sound ROM callouts or not. 905 does cause Rudy to blink, or it makes Rudy blink, which is kind of a cool feature, and I just love Rudy. Anyway, I did have to socket and replace 2803, 2 339s, this LS374, and those were all alkaline corroded. As you can see, I've sanded to bare copper on these traces, replaced 16 10K pull-up resistors, and this ceramic cap that is a high frequency filter for the 2803. I replaced the reset generator with the lower voltage reset generator. There are 2 components here, a 10K cap and a 470 picofarad cap, which I only had in a disc capacitor version. I don't like to put those in there, but sometimes I do. I clipped off the country codes to the left. These are the only 2 country codes that you need ever on any game that specifies USA 2. And so let's see if my alkaline corrosion has done the trick. Okay, so there's the 1 opto. There's the 2nd opto. Time and date not set. Let me turn off a light here and see if we can get this better. Oh yeah, much better. So let's get into test. We'll do the switch edges. And I'm gonna go across the diagonal of the switch matrix. Whoops. I think I got my fingers crosswise there. No, I did not. 55 and 75. Well, I'm pressing 55 and 75 is registering. That's interesting. I have to track that one down, but the rest of the switch I spoke too soon. Column 8, or is it row 8? Neither column 8 nor row 8 is being reported. Oh, that may be because FunHouse doesn't use column 8, but I'll have to look that up in a manual. All right, so I do have one switch matrix problem, and that is, let's see if it's column 5 or row 5. Column 5 appears to be working. Yeah, if you hold down row 5 and press any column switch, we're getting the wrong indication. So there's something wrong with the row 5 circuitry here. So I'll have to check for continuity, and I've got a nice map in the pin wiki that allows me to check from the row connector all the way up through the circuitry and figure things out. There was this chip was already replaced, and somebody hacked a trace onto the back of it. It looked okay to me, but it's possible that is the problem. We will see. Get out of switch test and get into solenoid test. And I've already tested this board with the official Williams test ROM, so I'm not going to find any surprises here. And all of these solenoid drive circuits are going to be working just fine. And they are. Let's go to GI test, and there was a blown fuse at F109. And I've got this handy cheat sheet. The orange lamp wasn't lighting, so I knew that was F109. Oops. Let's go through them. GI is working correctly. Let's do lamps and flashers at the same time. So these two circuits are not used apparently in FunHouse, but I will make sure that solenoid 21 and 22, all the lamps are working perfectly. Test the display. And the fella did send along his plasma display, which I rigged up to my FunHouse after adding some ribbons that didn't come in with the shipment, but that display is working perfectly. And I'll include the video of that. FunHouse, probably Pinbot too, does this test, which is the inverse one segment on test, which is kind of cool. Okay, now for the part we've all been waiting for.
We were pals. Get yourself a hot dog, you big sausage.
What was that? That's something Paulson used to scream at me over the telephone when I'd try to sing. He was a singer. I can't carry a tune. So when I'd sing something, he'd always reply with, "What was that?" in Rudy's voice. All right, so the soundboard is now working perfectly fine. I'm going to send along a replacement fish paper loop that protects people with hands in the back box of getting burned by this big old heat sink. But this heat sink is pretty cold right now. It's not going to be a problem with heating up, popping, etc., because I've already replaced all the components that would cause such a thing. So the last thing for me to do now, let me get back into switch test, is to figure out why row 5 is doing what it is doing. Right back. This is the diagram in the Wiki that I use to track down switch matrix problems, and I have an issue with column 5, or I'm sorry, with row 5, which is processed through this LM339. Now I found out something odd. Watch this. I'm just gonna pan back a little bit, and I'll put my finger on the PCB right here. And the capacitance of my finger to a trace there is causing a problem. So I went down here to this 339, and I'm going to probe pin 5, or sorry, the pin for row 5, and it's causing switch closures to occur. I'm not sure I got that in camera. Let me try that again. Sorry. That should not happen. So let me move over to row 6, and you can see it's high. This pin has got nothing on it, which means that there's something going on underneath there. So let me take that out and see what's going on. This, I'm pretty sure, is the problem. These are 10K pull-up resistors. They're connected to 5 volts on one side, and each pin, appropriate pin of the 339s on the other side. So this bank of 4 services this one. This bank of 4 services this one. I'm going to try to zoom in, but where my pointer is right now, you can see that this trace, which I've always thought was an odd trace, the way it's laid out, but there's no continuity between this through hole and this trace. Let me see if I can zoom in on that. Yeah, now you can clearly see it. Now, I missed that when I was abating the corrosion. I visually inspect these, but visual is not good enough, of course, unless you're Superman with electron vision. So I'm going to patch that trace up. Probably going to tack a wire to it and then go through the through hole, and she should be good as new. All right, I have forgotten which take we're in here, but we're back at it again on the bench, and we're going to test these switches. I did repair this trace. I ended up using a tiny piece of trace wire, came up through this through hole, and then tack soldered it to this trace that goes up through here. A lot of times you can't get a good purchase on the trace, so I would have done a point-to-point. I'd have soldered a wire from this pull-up resistor leg to the rear of this pin for the 339, but I think this repair is pretty solid, so I'm pretty happy with that. So let's see if I'm talking so much. Let me see if it's actually repaired. Going through the switch matrix diagonal like I do now. Oh, interesting. Okay, so we have an interesting collision of things here. Here's 77, 66, 55 is an opto, and it only registers after the switch pair has been released. Now let me try some other switches on row 5, and you can see those are working just fine. And here's the opto. You can see it registers after release. So these are all working correctly now. I did check the FunHouse manual, and column 8 is not used, so there's never anything going to be reported by the software for column 8. Now row 8 works like it should, but column 8, no such thing. So let me go through that diagonal one more time. Remember, this is the opto, and I got a same message on, I think it was switch 51. Yeah, so I just did that. That's the other opto, the one that's in the I think Rudy's mouth. Let's not cut him down and call him a dummy. It's Rudy's mouth. And every time you hit it, you get something like, ow, I thought we were friends. So now we have the switch matrix is operating correctly. I did end up replacing this 339 because in my estimation, that was the highest probability. Since there was corrosion under this series of chips, I wanted to make sure there was no corrosion underneath here. There didn't turn out to be any, and then I found that discontinuity in the trace. I could have found it quicker, but that's the way it goes. So let's see, we have repaired the MPU board. That's everything that was done to it that I recollect. We have repaired the driver board, and that's everything done to it also. Here's the voltages coming out of the driver board. 493 is the 5 volts, 11.9 is the regulated 12, 15.1 is the unregulated 12, 21 is flasher, and 72 is coil power, which is normal despite the fact that test point 6 there says 50 volts. WPC is in fact about 70 volts. So I think that's it. Thank you so much. I'm looking forward to the pictures of this totally restored FunHouse that a fellow is putting together. Thanks again.